Hello everyone, welcome to my class, Math Lesson with Miss Kenny. Today we are going to learn about algebra, how to solve quadratic equations by completing the square. Previously you have learned about algebra, how to solve quadratic equations by factorizing. Let's see the advantage and disadvantage of using factorization method. The advantage is it's easy, but not all quadratic equations can be factorized. For example, x squared plus 5x plus 7 is equal to 0. Find two numbers that when you multiply them together, the product is 7. And when you add them up together, the result is 5. 7 is a prime number, so it has only two factors, 1 and itself. 1 times 7 is equal to 7, but 1 plus 7 is not equal to 5. So we cannot use factorization method here. We are going to use perfect square. In elementary, you have learned about perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4. In algebra, we are going to use algebraic perfect squares. Involving addition, for example, x plus 1 times x plus 1, x plus 2 times x plus 2, x plus 3 times x plus 3. To keep it simple, I'm using the index form, x plus 1 squared, x plus 2 squared, and then I expand the algebraic perfect square. I'll get this result. For example, x plus 1 squared is equal to x squared plus 2x plus 1. So there is a pattern here. I can formulate the algebraic perfect squares as x plus a squared, because x here is not changing and the constant term inside the brackets is changing. So I can use the variable, the letter a. And then the quadratic term is not changing. So the quadratic term is x squared plus the linear term. See, the linear term, the coefficient of x is changing. So they are making a sequence. As you can see, a sequence, an arithmetic sequence. If a is the position number, then I can formulate the linear term as plus 2ax, like this. Because 2 times 1 equals 2. 2 times 2 equals 4. 2 times 3 equals 6. 2 times 4 equals 8. The constant terms here, as you can see, they are perfect square numbers. So using a, we can formulate the constant term as a squared. This is how we formulate the algebraic perfect squares involving addition here. What if the algebraic perfect squares involving subtraction? As you can see, for example, x minus 1 times x minus 1, x minus 2 times x minus 2, x minus 3 times x minus 3. Using index form, to keep it simple, you can write them down as x minus 1 squared, x minus 2 squared, x minus 3 squared, x minus 4 squared. And then using expansion, x minus 1 squared is equal to x squared minus 2x plus 1. There is a pattern here, so I can formulate a formula for the algebraic perfect squares. As you can see, since x inside the bracket is not changing, I can use the x and then minus a, using the variable here because the constant term is changing. The constant term inside the bracket is changing. And then the quadratic term is x squared because the quadratic term is not changing. And then the linear terms. As you can see, the coefficient of the x are making a sequence, an arithmetic sequence. Using a as the position number, we can formulate the linear term as minus 2ax. And then the constant term here, the constant terms are making a sequence, and they are making a special number sequence. As you can see, perfect square number using the a variable. We can formulate the constant term as a squared like this. Now we have the formula of the algebraic perfect squares. The perfect squares, the x plus a squared and x minus a squared, are known as special algebraic identities. And not only these two, there is another special algebraic identity. It's difference of two squares. You have learned this previously. For example, x squared minus 4, and I change 4 into index form into 2 squared, like this, x squared minus 2 squared, and then I can factorize the quadratic equation, x minus 2 times x plus 2. So 1, 2, 3. There are 3 special algebraic identities here that we are going to use to solve the quadratic equations. Let's take a look at the example here. The instruction is solve the following quadratic equation by completing the square. As you can see, x squared plus 5x minus 7 is equal to 0. The first thing you need to do is just to remember about the expansion of the algebraic perfect squares x plus a, because as you can see, the linear term here is positive. So use the algebraic perfect square using addition here, x plus a squared, and then expand x squared plus 2x to ax plus a squared. And then, as you can see, x squared, the quadratic terms here is the same with this one. So we can go to the next linear term. We can break 5 into 2 times 2.5x. So we can get the value of a. The value of a is 2.5, and use it to create the constant term here, a squared. So 2.5 squared. And then move the constant term from the initial quadratic equation behind. Now, using balance method, if you put plus 2.5 squared on the left side, you need to put plus 2.5 squared on the right side of the equal sign too. So now, see this, we can replace these with the perfect square. So we can just write x plus 2.5 squared like this. And then minus 7 equals 2.5 squared. You can use your calculator to calculate the 2.5 squared is equal to 6.25. Okay, and then use the balance method to eliminate minus 7 because we want to isolate the perfect square, this perfect square. Okay, and then 6.25 plus 7 is equal to 13.25. Now I want to remove the square here by adding square root on both sides, and don't forget to put plus minus sign on the right side, because if you multiply positive number by a positive number, you get positive result. But if you multiply a negative number by a negative number, you also get a positive result. So you need to put plus minus sign here. So using your calculator to find the square root of 13.25, you get 3.64, as you can see, and then split the equation into x plus 2.5 is equal to 3.64, or x plus 2.5 is equal to negative 3.64. And then using balance method to find the solution. X is equal to 1.14, or x is equal to minus 6.14. Don't forget to underline your final answer twice. Okay, what about if the coefficient of the x squared is not equal to 1? For example, the coefficient of x squared here is equal to 2. What you need to do, you need to factor out 2. So 2, open bracket, x squared minus, you need to divide each term by 2. So 3 divided by 2 is 1.5. So since there is a negative sign, we put negative sign here. And then 4 divided by 2 is equal to 2. And don't forget there is a negative sign here too. Now we have the quadratic equation, okay, with the coefficient of x squared is equal to 1. Now it's time to use the algebraic perfect squares using the special algebraic identity like this. Okay, since the linear term, the sign of the linear term is negative, use the negative 1 like this. And using expansion, now we need to use the equation inside the brackets only. No need you can leave out the 2 here. So we need to break 1.5 into 2 times 0.75. So we can get the value of a, and after that we square the value of a. The same way with the previous example. Okay, using balance method, if you put plus 0.75 squared on the left side, you need to put plus 0.75 squared on the right side. The same, and then replace this with the algebraic perfect square. Okay, x minus 0.75 squared minus 2 equals, using your calculator to find the square of 0.75. And then using balance method to isolate the perfect square. Here, this is the perfect square. And then use the square root to remove the square. And then use your calculator to calculate the square root of 2.5625. Okay. Now you have this equation. You can split the equation into x minus 0.75 is equal to 1.60, or x minus 0.75 is equal to minus 1.60. So using balance method, we can find the solution. X is equal to 2.35, or x is equal to negative 0.85. And don't forget to underline your final answer twice. This is how we solve the quadratic equation using completing the square. Okay. Thank you for watching Math Lesson with Miss Kenny. Bye-bye.